Hello, and thank you for having me at the Technology Modernization and Innovation Conference. A couple of themes for this session, just to give it a quick introduction. Really want to talk about systems and data. So really how we're sourcing, consuming, using, and exposing data and between organizations, within organizations, and what systems we're using now and kind of should we be using, and how technology kind of overall and technology trends play a role in that. And really the main theme being kind of how to leverage best practices while modernizing, whatever you're using now or legacy systems into these exposed, efficient, data efficient systems. That's the goal. So first, a little bit about me. My name is Kelly Dyer. I'm the co-founder and CEO of SourceFuse. I'm also the founder of a few other technology startups, as well as previously a consultant for Accenture. Developer by background, but after an MBA from Duke, turned more on the business side, and really I really enjoy diving into that bridging that gap, not just kind of the cloud, but how do you modernize your applications? How do you solve business problems or real world problems, or and actionable problems with better systems and better data? And that's what I enjoy doing. SourceFuse as a whole, we've been around 15 years. We have 5 global locations. We're advanced consulting partner with AWS, although we do work with other clouds as well. Really have a broad range of competencies across healthcare, public sector, and others. Beyond the cloud providers, we do work with other technology partners, really to support this whole microservices and modern way of doing things, whether it's Twilio for messaging or New Relic for monitoring, or some of the others here. We believe in tech partnerships and using best-in-class applications to get the job done. So really the challenges in what we're talking about modernization really come down to a couple of concepts. One being legacy systems. A lot of times you've got different applications written in different languages over different times, and have been merged from companies or departments coming together and really kind of doing their own jobs and apparently doing them well enough, but they become hard to maintain, and especially when there's a lot of them. And there's a lack of interoperability between them in most cases. So you end up with these monolithic architectures that become costly to support, like less than efficient from a speed and storage perspective, and just really a management challenge. And then with that, you have legacy data. You have data in different databases, different structures, usually don't talk to each other. Sometimes are very large, different formats. And so really your data is siloed within these legacy systems. So you're not really able to pull them out and make use of them in the way you could if you had a more valuable structure that supported that. So the topics I'm going to be covering here around this modernization is really how to go about it. You can't take a large set of systems that have been doing their jobs for a large number of constituents and just rewrite them and instantly move things over. That typically doesn't work. It's rebuilding your car while you're driving 70 miles an hour down the interstate. Instead, you really need a framework to go about it, and you do it in a logical order. And this is what we've seen to be kind of a best practice and most successful. So a couple kind of main fundamental business concepts to think about in the technology approach here that I'll be covering in more depth are kind of listed here. So cloud native computing. So we're being native in cloud environments, and I'll dig more into what that means. And the concepts of thinking API first. There's a whole lot of advantages to thinking and starting your application and your business level design really around the interactions between systems and building those APIs as the first part, and structuring your systems accordingly for that. Another topic being containerization, which fits the same model of standardizing how and where your software runs, and making it really easy to do that anywhere it needs to be to create that ultimate flexibility in how you use your software. And then the microservices architecture, which lends itself to the API structure, but really goes even deeper, even internally in the application, thinking about small microservices doing their jobs that they're meant to do. And we can get into some of the advantages of why that's a good way to think about it when you talk about modernizing software and access to the data that software is exposing. So first step, cloud native. So when we say cloud, it doesn't have to be AWS is Amazon's cloud. You've got Azure, that's Microsoft cloud. You've got Google cloud. You've got Salesforce cloud. There's a bunch of public clouds that you can use there. You can have your own private cloud infrastructure, your own hardware. If you have really strict data requirements about where the data resides or any of those, you can run a private cloud, or hybrid clouds, that actually have this multi-cloud environments. These are all kind of common, and they become available to you when you kind of have modernized application where You can have data living where it needs to live and systems running where they need to run and not be really constrained by where that happens to be. So you do get speed by nature, reusability of these environments that you can roll out. You can even structure and streamline how a whole entire version of your application gets rolled out. And even if you just needed to use it one time. And that's where the on-demand infrastructure comes in. You can really upgrade and manage, aspect of your infrastructure without actually physically adding hardware like you would have to in a data center. And then, on the underlying layers here, the continuous integration, continuous delivery, and the whole DevOps kind of concept of how you manage code deployments and application, where they live, and being able to push out new ones and streamline that whole pipeline for how software gets managed and rolled out. There's a lot of tools that are in the cloud that allow you to do this in seamless, real-time ways without downtime, and these are powerful aspects that come into managing software when you want to move quickly and have the ability to basically scale as much as you need, even if for just temporary environments. So now the other concept, when thinking API first, so really the API is the application programming interface. It's how systems talk to each other, and they're common use now. Interoperability is a big tool going on, and it's how systems should be built. So you can expose data in a structured way, and you can expose business logic in structured ways, so that they can interact internally within that structure, or even expose them externally to partners. So when you think about the API first, you really kind of can think about the structure of those interactions first and define the APIs. And you can test against that. You can spit those out before you've written any code. You can look at how interactions are going to happen and make sure they meet the business logic. So when you start that way, you can move faster on integration between systems because the APIs are defined, even if the backend business logic isn't written yet. You really kind of can decouple different sets of functionality and really give structured input-output requests to those, and let them live wherever they live. But it's really speaking through the API is really how it interacts with your other systems or your other partners. And you're really kind of decoupling where are all these business logic and pieces run, and so you're not really constrained about a large environment. You can have really sets of interactions between environments. So along with that is the concept of containerization. So you package basically the entire computing environment in a container as a virtual container, and so that can be dropped into any other environment. So a developer's local machine to be quickly up and running with software, to a particular cloud environment dropped in and deployed for a development or a testing environment, or to your production. It's the same computing environment deployed all at once, so that there aren't external libraries or dependencies or operating system requirements that all of a sudden create challenges between environments. So you really get this standard and consistent way to deploy flexibly across anywhere you want to put that code or application. And then the microservices architecture really kind of is how to think about the business logic and how that maps to the technology and the systems and the data structure. So in thinking about it this way, you're looking at microservices on this right, as opposed to, let's look at a legacy and monolithic. You have a big database, and you have your business layer, and you're providing that with some kind of interface, and all kind of lives together in some collection of libraries and code. But really, in a microservices environment, each area might have its own function for that aspect of your system it manages, and it's got exposed APIs that other services can interact with, and so you can really drive nuanced business logic and data access at this microservice layer, where it's really exposing and interacting with what it needs visibility to, but being entirely independent from the rest of your application. So this creates the ability to move quickly. You can roll out one service that starts getting used and exposed, and then add in others, and you have an architecture now to move towards modernization. It's very scalable because any one service and data can kind of expand as much as it needs for its usage without really having to scale or manage the rest of your systems. And deployments and management of these becomes easier, because when you make a change or an improvement or new technology comes along, you can really replace this one section without really impacting the whole entire application, having to manage that aspect of it. And really around the cloud environments, the other advantages you get are this advanced tooling we have these days, and managed providers that are available can really constantly monitor for security and compliance related issues, and detect and fix those quickly or even automatically. Reliability and being up and being able to scale your hardware, your software, your processing, your interactions as much as you need at the push of a button. While at the same time managing your costs. You can look at where what is most expensive, whether that's in time and processing, or if it's actual money, and kind of where in your application that is, and you can react to that, and you can make changes that all of a sudden you can optimize and remove those costs, because by having it broken up and in a cloud infrastructure, you can more easily manage and optimize for whether performance, cost, and everything all at the same time. So in practice, a framework that you could look at for this is one we've worked with. Is the foundation is called Loopback. It's an IBM-backed enterprise-focused framework, and we've expanded that. It's called SourceLoop, which is an expanded version of that, and really it has these elements that I'm talking about. So if you pick a framework that is based on microservices approach and an API-first model and a cloud-native, structured environment, that's the starting point for how you think about modernizing it. And really being open source means you're kind of free of any kind of vendor lock-in and constraints, and you can manage, you have full visibility into it, which is important and better from a security perspective. And really you can move down a rapid development pipeline where you take one service and you're exposing and consuming that layer, and then you can add another one to this mix and another. And so you can really move towards this modernized application in pieces, service by service, and it gives you kind of a framework and a structure to do that meets all these tenets that we're talking about, like how you should really be thinking about changing it. Gives you a framework to do that with it. So really the goals are clear. You want to reach efficiency. You want to expose your data. You want to rewrite. You want to replace legacy technology that's either hard or costly to maintain. But the real goal, the end goal, is really maximizing the value of your investment, and that's really about your systems themselves. How you're using them, how can they do their job better? Can they serve your purpose better? And your data, by exposing your data in these ways and making it more available, you can create more freeform interactions and openness of information, which is really where a lot of the value is stored, is data that's you're bringing it out of the silos and you're opening up the ability to for layers of interaction that never were possible before.